Today we're going to be talking about 10.3, solving quadratic equations by graphing. So the first thing you need to know is like the different forms of the quadratic equation. So the first thing we're going to look at is algebraic. Now we have already looked at ways to solve algebraic, and this is typically standard form. And the one way that you already know how to solve algebraic is by factoring. And notice it's equal to 0. Well, today we're going to look at graphic solutions. So what has to happen is that the 0 will then become a y equals, and it will also be standard form. And then also we're going to tie in the function notation and look at how the names of the solutions change. So a function notation would be f of x equals ax squared plus bx plus c. So remember, anytime you're trying to solve a quadratic equation, you're trying to find out the solutions that will make x work. So we know how to do that by factoring. Now we're going to look at how we do that graphically. So example 1 says solve a quadratic equation having two solutions. Solve by graphing. Notice you do not see a y equals. So we've got to get the 0 to appear so we can replace that with y. So we're going to go negative x squared plus 2x plus 8 equal to 0, and then we're going to change that 0 to a y. Now, to be just a little bit quicker, we're going to type this into our calculator, and we've got it here. I'm going to go to my table, and I'm going to look for my vertex. Now, you know how to do this by hand, but right there I have symmetry, so I'm going to graph 1, 9. I'm going to graph 2, 8. And then I'm going to graph negative 1 or 0, 8. And then I'm going to graph negative 1, 5. And notice it's got negative 2, 0 on it. On the other side, I see the 3, 5. And then I see 4, 0. And remember, I've stressed all week that you need to extend it to where you can have those x's touching. Now, please notice these are the most important things we're looking for today because those are our x-intercepts. Now, from previous lessons, you should know x-intercepts are the solutions to the equation. So the solutions to this could be and will be negative 2 and 4. Now, remember the significance of those. If that's negative 2 and 4, then I know this equation will factor. And we could have factored this. Okay, I'm going to take the negative out. And it's going to be x plus 2 and x minus 4 equal to 0. You can see your intercepts. You can see them here. Therefore, they're solutions. But notice it says two solutions. Why does it have two solutions? It's because it has two x-intercepts. But does that always happen? So let's look at example 2. It says solve a quadratic equation having one solution. So here is the equation. Once again, I need to make that 0 appear. So right there's the equation. Change it to y. Once again, to save a little bit of time, we're going to do this on our calculator. So it's minus 4x and it's plus 4. I'm going to look at my table. Remember, I am searching for symmetry. Right there it is. So it's 2, 0. Now notice where that 2, 0 is at. And this happened in your homework last night. It is the vertex of our graph because we have 3, 1, we have 1, 1, we have 0, 4, and we have 4, 4. So I'm going to draw the parabola. And notice you only have one x-intercept. So why did that happen? And what is the answer? So the answer looks to me like is going to be 2. But we've got to realize why that happened. So let's factor this. Notice how it's a perfect square trinomial. So x minus 2, x minus 2. So it's the same factor. If I set this equal to 0, I will only produce one answer of 2. So that should be a connection to your perfect square trinomials that it only has one solution, and that one solution is the vertex of the graph. Now, we have two solutions. We have one solution. The only thing that's left is to solve, and that's misspelled, to solve a quadratic equation having no solutions. So let's look at this one. So we have x squared. I need to bring the 2x over here, so it's going to turn negative, plus 8 equals 0. So this one here, I'm going to do on the calculator again. So I have x squared minus 2x plus 8. I'm going to look at my table, and I see my symmetry right there at 1, 7. So I've got 1, 7, 0, 8, 2, 8, negative 1, 11, and 3, 11. Now notice the parabola. Why does this parabola not have any solutions? Well, it does not touch the x-axis at all. So think about it. Will this factor? Can you think of any factors of 8 that'll give you negative 2? Well, 4 and 2 will give you negative 2. Okay? However, it doesn't give me a positive 8. So this one will not factor. It also has no solutions. So this one right here would be classified as having no solutions because it does not touch the x-axis. Now that's the three things that can happen with a parabola. It can have two intercepts for two solutions. It can have one intercept for one solution. Or it can be totally above or below that x-axis and never ever touch it. So let's go ahead and summarize this here. Okay, it says it has a quadratic equation has two solutions if the graph of its related function has two x-intercepts. A quadratic equation has one solution if it has one x-intercept. And the quadratic equation has no solutions if it has no x-intercepts. Okay? Now let's put this together with function notation. Notice the directions change. It says find the zeros of f of x equals negative x squared minus 8x minus 7. So we're switching notation, and it switched to a different word. It didn't say solutions, it says zeros. That's because in function notation they're called zeros because we are looking for the values of x to make the function equal to 0. So we're going to do this one on our calculator once again. So I have it typed in right here. So I'm going to go to my table. Oops, I graphed it. But you can see it's going to have two, but we've got to figure out what they are. So let's see if we can find symmetry. We sure did. It is right there. So let's graph negative 4, 9. Let's graph 0, negative 7, because that's going to be way down here. So that's going to make it cross. So let's go ahead and graph negative 3, 8, negative 5, 8, negative 6, 5. Okay, and I've got negative 7, 0, and I've got negative 1, 0. And remember, that's what we're looking for. I just graphed that one wrong. Okay, so when I look in my table, this is what I care about, the negative 7, 0 and the negative 1, 0, because those are my x-intercept. So what we would now say is that the zeros of this function, okay, is going to be negative 7 and negative 1 here and here. So I put everything in a chart for you so you can make sense of this. The solutions of an equation, and this needs to be equal to 0, are the numbers that make the equation work, that makes it equal to 0. We can factor this to find them. That equation factors like that. Therefore, by looking at this, my solutions are a positive 9 and a 2. Those are solutions. That is algebraic. The x-intercepts of the graph of it occur when 0 is equal to y, and the x-intercepts are 2 and 9. Notice algebraic graphic. Extending it to zeros of a function, it says the zeros of a function are the values of x for which f of x equals 0. So the zeros are 2 and 9. So they're all connected. Algebraic, graphic, function. Okay, different names. Solutions, x-intercepts, zeros. Now, pause the video and just go through these last questions and see if you can tell me how many solutions of each graph. Okay, the first one was no solutions. Granted, it's way above the x-axis. The second one is -2 and 2. Those are our x-intercepts and our solutions. And the third one is 4 and -4. Be careful with the scale here. That had 2 solutions. If you have any other questions, please see me at flex time or during class.